Hi, everyone. So about 125 million years ago, the first thing that we would consider to be a seed appeared on planet Earth. About 124 million years later, human beings showed up. And in that time, and this was about 80,000 years ago, human beings, we were foragers. We would try to find food wherever we could get it. And that went on for about 60,000 years until you reached the point where, after being a hunter-gatherer, we started to build social concepts around food. And that really led us to the cultivation of agriculture as we know it today. So for the last 12,000 years, humans have been cultivating crops. So it first started with wheat and barley, and in China, simultaneously around the same time with rice. And what's interesting is agriculture and cultivated agriculture actually have completely changed the way human beings lived. The first walled cities, which appeared in Sumeria, Mesopotamia, occurred right around the same time period. So the first walled cities of Jericho and Palestine were really a reflection that humans could now stay put in one location, could actually grow crop, and didn't have to roam the earth anymore. So for about 11,900 of those years, farming pretty much went the same way. And it really wasn't until the last about 120 years that we saw some major changes with human beings, again, bringing technological ingenuity to farming. It first started at the beginning of the 20th century with the mechanization of farming. And in fact, in the imperial metric system, we use the word acre to measure land, and acre comes from the Old High German word acker for field, because it's literally the amount of space that one human and an ox could plow in one day. And if you fast forward 120 years, a tractor now can cover 40 acres in just 1 hour. So it completely changed the ability for how we were able to scale agriculture. About 50 years later, we saw a breakthrough in chemistry right here in Germany. So Fritz Haber was a German chemist who actually found a way to get nitrogen out of the atmosphere and get it into the ground. And then Bosch, who is the brother of Robert Bosch, the founder of Bosch here, actually found a way to commercialize and productionize, and that gave us synthetic fertilizer, probably one of the greatest inventions in our lifetime. And then we saw the evolution of crop protection products, whether it's herbicides, fungicides, pesticides. We saw the hybridization of seeds. And really, since the 1950s, the world has enjoyed 150% more food production on only 12% more land. But it's come at a cost. Intensive agriculture has had an impact on the world. Today, farming is responsible for about 1/3 of greenhouse gas emissions, consumes about 70% of the world's fresh water usage, and that's about 30% more fresh water than we can actually replenish naturally. We lose about a football field of soil on planet Earth every single day. And if you look at all the soils that cover our farmland in the world, they've lost about 50% of their carbon content, which is a non-renewable source, since really agriculture intensified about 100 years ago. So we're now looking for what's the next level of change in agriculture, and what we see is the opportunity to move into bringing computer, data science, or digital technology into the farming world. And so this is what Syngenta, and we are one of the world's largest agricultural companies of the world, helping to build products to allow farmers to be successful. So in the world of digital technology, we're really working on 3 potential opportunities. One is, how do we make farming more sustainable? And while you're doing that, how do you improve food production for a world whose population is growing? And then how do you make farmers more profitable? I think, as you had heard from the last speaker, it is becoming more and more difficult for farmers to be successful. So if you take them one at a time, the world clearly wants less pesticides, and we're one of the world's largest pesticide manufacturers. So what we have to do is we have to find solutions that actually can help farmers and ultimately the consumers who are driving that demand address those issues. You can't get rid of pesticides immediately, because if you did, you could deforest the entire planet Earth and still not make up for the lost amount of production use that you'd lose by completely banning all pesticides worldwide. So there has to be a middle ground. So we're working on digital technology where you can scan one of our bottles, and we're doing this prototype actually right here in Germany. You can scan this bottle, and it actually can push the prescription of how to use that product responsibly. So we can map a farmer's field, we can see where waterways are, and most of this technology, like a sprayer, is more or less autonomous. You can fine-tune and control automatically every single nozzle of a sprayer. So being able to take that and ensure that We remove all the human problems that could cause by overspraying or not spraying in the right places and allow autonomous sprayers to really do their job and maintain, for example, a 10-meter buffer between the crop and a waterway. So these are products that we're working on right now around sustainability. In the US, we work with companies like General Mills and Kellogg's to help them make sure that they've got an agricultural supply chain that is sustainably grown and that they can market that for their cereals. But we also take the farmers as part of our program that are using our digital tools, and we give them the opportunity to benchmark how sustainable they are relative to other farmers who grow in similar circumstances. And then, of course, the concept of See and Spray. When you think about the use of herbicides, sorry, we're missing a page here. This is the concept of being able to put an image of a field, have a camera with machine learning and computer vision on the field, and be able to only spray in small microdoses just the weeds, keeping all of the ground that doesn't need the herbicide completely left alone. This has the opportunity to reduce herbicide use by 90–95% in some studies we see. So we're working on products that can begin to be working in microdoses and formulated that way to really radically reduce the use of pesticides. So crop planning. So about less than 25% of farmers use software to help them do profitability and crop planning. And that matters because the differences we see between farmers that use the software and don't could see a difference of up to 30% in profitability. But you might be wondering why we should care so much about farmer profitability. Well, here in Germany alone, the government will spend about 11 billion euros on agricultural subsidies just this year. And it's becoming increasingly difficult to farm in a world of climate change. A 2-degree increase in climate, in heat, will actually result in yield of wheat, which is the largest grown crop, and the largest grown crop here, particularly in Northern Europe, would be reduced by 48%. It already makes it very difficult to be a farmer. So creating these tools and providing them to farmers to allow them to make sure they're making good decisions, to not spray when they don't need to manage resistance pressure, these kinds of things are tools that we already have in the market. Managing variability. So today, a lot of times, farms are being managed on average yield, average rate, these sorts of things. But what sensors and computer image technology allows us to do is it allows us to break farms up into much smaller units, into grids. That allows us to manage the variability of the field, not just the broad averages. And that allows farmers to really be able to do much more nuanced applications and monitoring and scouting to help them be more productive. And then finally, in the area of profitability, how do you start to connect growers with consumers to reestablish trust in our food supply, but also to give growers that are growing responsibly and growing sustainably an opportunity to charge a premium for their products? So today, this is in China. If you go to an Alibaba grocery store, and yes, there are Alibaba grocery stores in China, you will see these red strawberries that are about twice the cost of a normal strawberry, that on it is a QR code. Our logo is on there. You can scan the code, and you'll be able to see when those strawberries were planted, picked, what temperature they were stored at, whether or not pesticides were used, who grew it, what part of the country it grew in, how long it took to get there. This fundamentally has the ability to alter, because right now we still view food as a commodity, but over time we view that this type of technology and traceability will not only allow a reestablishment of trust in the food chain, but also allow farmers the opportunity to charge premiums based on the types of components that consumers want. When you think about genetics, there's 30,000 varieties of wheat. And as climate change occurs and as soil compositions change, how a certain variety of wheat will perform differently depending on the soil and the environment that it's in. So you need technology, and we've built seed selectors now which allow growers to understand, given the specific parameters of their field, what genetic variety is most likely to succeed. You heard the last speaker talk about a shift from worrying about frost to worrying about drought. That's where really genes and the hybridization of seeds comes into play. So the ability to algorithmically understand and model how these seeds will perform in the real world could make the difference between a failed crop or a highly successful crop. And even how they're placed. Depending on the soil and the way the genetics work, if you have seeds that mature at different rates, the seeds that mature faster will compete and actually win and steal nutrients away from those that are less mature, causing a real uneven crop growth. So we've built algorithms that take those genetics in the environment and can accurately prescribe what's the space and depth of those seeds based on the specific print of that farm. Computer-aided scouting. So today, plants, they absorb and they emit solar radiation as part of the process of photosynthesis. This solar radiation is actually not perceptible by the human eye. It's at a light spectrum that humans can't see. So today, using satellite images or even drones, you're able to actually pick up those wavelengths. And as we start to build predictive models around the growth pattern of a specific crop in a specific region, we're able to give farmers early warning indicators about whether or not the amount of sunlight is being absorbed or reflected in the way that it's supposed to. This gives them the ability to intervene before there's a problem. So there's a lot of exciting things that I've showed you here related to digital, but as I mentioned, it's related to hardware, algorithms, and software all working together. And so while we're excited to be working with Bosch on their Nevinex program, is the software and algorithms which we are very hard at work on ultimately won't matter if you can't put them into the implements that can actually deliver the planting and the harvesting and the plant protection part of it. What we're working with Nevinex on is finding a way to create more of an open community that allows different types of equipment manufacturers to work together to use these algorithms and this software to make a difference for farmers. So we're very excited about our partnership with Bosch on this, and we think the world needs to work together. The agricultural industry needs to work together to be able to deliver these solutions and bring them to market. Thank you.